All right. Thank you all for joining us today for the first of the ICEA Tech Showcase webinars of 2024 and our first with the Ferryfield group. They're going to present today with us Road Mapping to Project Risk Modeling Maturity, Integrating Cost and Schedule Risk Analysis. Today you're going to hear from Doug Oldfield. He's from Ferryfield, and he's been around for 25 years, and he knows more about himself than I know about him, so I'll let him tell you a thing or two. And if you have questions for Doug, please put them in the chat. If we have time to get to them at the end of the session, we will cover them live. If not, we'll make sure your question gets to Doug and the folks at Ferryfield so they can help you offline. Until then, if you need anything else, tech support during the meeting, send me a chat. And until then, take it away, Doug. Thank you.
Thank you very much, Megan, for the introduction and also for having me along today. So welcome everybody. Happy New Year. I see some familiar faces and names on the list of attendees. So it's nice to see people again, and nice to meet you if we've not met previously. So what I'll do then, I'll give a really kind of quick overview about what we're going to be covering today. There's a fair amount to get through, so I'll just kind of go for a few kind of PowerPoint slides, just kind of talking a little bit about the agenda, and then we'll kind of get into the meat of the presentation. So what we're going to be looking at today really is some ideas around what's kind of current, kind of best practices or some of the things which are really important to try and get to from a project risk modeling perspective. So looking at cost and schedule, and then how we can integrate both of those things together. So just as a kind of really brief bit of background, although Megan said 25 years plus, I think maybe she was referring to myself and my business partner, Craig Ferry, in total. I've been working in the space for around about 15 years. Sometimes it feels like 25, in fairness. Other times it feels like about 3 years. So it's time seems to expand and contract in strange ways nowadays, it seems. So I've been working really in the field of quantitative risk analysis since 2008 when I joined an organisation called Palisade, as they were back then, who make a tool called At Risk. And I looked after the Middle East and parts of Africa and the UK, and did lots and lots of work for Palisade in lots of different geographies and different types of quantitative risk analysis. Then just 3 years ago, almost to the day actually, I set up the Ferryfield group with my old boss from Palisade, called Craig Ferry, which is where the name comes from. And really, since then, we've been really mostly focusing on the project risk space, and really looking at how quantitative risk analysis from the perspective of cost and schedule within projects. So in that time, I deliver lots of training courses, we do consulting, we also act as a reseller for some software companies as well. So, but really the key focus is in the field of quantitative risk analysis. So in terms of the agenda for today, as I said, there is an awful lot to get through. So we'll have a really kind of quick, but I guess kind of setting up what the presentation is going to be focusing on. So we'll kind of talk about, I'll very briefly explain a little bit about how people have approached project cost and schedule risk analysis in the past, what's kind of going on at present, and kind of what are some of best practices and some of the new things that you might not be aware of, particularly if you've been working in the field for a long time. I appreciate it's not always easy to kind of stay on top of kind of new technology and new practices. So hopefully today we'll illuminate some of those things for you if it's something that you've not been kind of looking into recently. So we'll look a little bit about what this kind of this hybrid approach to project risk analysis means. So kind of the difference between looking at a CPM for schedule and then a cost model separately. How can we start to integrate those in theory? Then we'll look at what that kind of looks like in practice, I guess. What's the kind of the different elements that we might need to think about? So we're talking about schedule, talking about costs, and talking about risk registers, and how we can start to bring together those independent, or those areas which are very silo based historically. How we can start to break down some of those silos a little bit. We'll also talk about sensitivity analysis and stochastic optimization. So how we can use the analysis that we've, or the outcomes or the outputs from the analysis that we've done, in order to start thinking about what's the, how can we deliver better outcomes on our project, whether it's from a schedule perspective, whether it's a cost perspective, or even both of those things together. hopefully, assuming we've got time, we'll then start to look at how these things all start to gel together in lots of different ways, talking about things like scatter plots and joint confidence levels for those of you who haven't heard about those before. And then hopefully we'll have time for some questions at the end. So, um, in terms of kind of historically, really, back when I started off working with Palisade, when talking about project risk analysis, there was two distinct kind of silos. And in the kind of cost side of things, typically people will be using an at-risk or crystal ball, or later on something like a Vose model risk. And on the schedule side of things, whether they kind of use PERT master or Primavera risk analysis slightly later on, it's a good way to carbon date someone within the project risk space as to which of those kind of tools that they're familiar with. These activities were often done in a kind of like an independent way. So you might have the cost team building a model to understand what their cost risk exposure looked like, the schedule team doing exactly the same for schedule, and the closest anyone ever really came to doing any kind of really good integrated analysis was maybe coming up with a PAT from the schedule outputs, applying some kind of daily burn rate to it, whether it's the kind of like the activity or phase level, and then that would form an input to the cost model. Not very holistic. And so that lack of I guess completeness in the modeling sometimes really doesn't give us good answers as you might expect, and we'll look at why that might be important in a moment. So then something which some of you may have heard of, some of you may have done, some organizations do this, many don't, is the idea of maybe building up something like a resource or cost loaded model, where you might have a cost model which was previously in a cost breakdown structure, maybe being held in an ERP system like SAP or something else, and that would need to be kind of massaged into a schedule, and all the cost of the resources and material costs, etc., and everything would be linked within the schedule. Although you get some good outcomes from that, it's an activity that's not necessarily very simple to do. And so some organizations don't do it because it's too much hard work. Others don't do it because they or do it badly. So it's something which historically hasn't been done really to the maximum benefit of organizations, if you like. So of course, when we look at projects, whether we're talking, I don't want to point fingers at cost or schedulers independently, because when we look at the statistics, when we look at the outcomes in the project space, projects are prone to overrunning on both cost and schedule. Sometimes it's all about the schedule overrun, which is typically you might see on some projects, but then other projects where there's a really set in stone completion date, like the Olympic Games or the World Cup or something like that. Those things don't tend to overrun on schedule, but inevitably the costs get out of control. And so really what we're kind of looking to do, this whole point of project risk analysis is really, it's about trying to understand what might happen in the future so that we can ultimately try and make some better decisions about in the present day and manage our projects better. And so in order to do that in a really kind of I guess comprehensive way, trying to divorce schedule from cost is something which is just fraught with danger, and I think that what we're going to be looking at over the next 45 minutes or so is not just about the outcomes. It's not just about the outputs that we get. Really, what I'm kind of hoping to ignite a spark, if it's not already there, is this idea that the process of getting towards an integrated cost and schedule risk analysis is something which has got huge benefits in itself, even without starting to look at the output. So it's about really joining up these different disciplines and really trying to maximize the expertise and really leverage the expertise of people on schedule, people on cost, bringing them together in order to make a model that sings all sorts of really kind of interesting tunes and songs for us. So I appreciate that the AAC, I don't know how much of a dirty word it is within the ICEAA, but the AAC is an organisation that I've done quite a lot of work with over the years, and certainly one of the kind of the things that I've been kind of looking at recently is looking at what kind of framework can be used for bringing together these two separate disciplines, or historically separate disciplines, of a CPM critical path method model for schedule risk analysis and a kind of hybrid parametric type cost model. Now we can start to bring those together, and what are some of the things that we need to think about. And so a decent part of this presentation will be kind of exploring this. I won't be kind of referencing this guide again, believe me. But a lot of the kind of techniques that I'm showing are kind of some of the foundations of this particular recommended practice, which obviously very, very happy to kind of talk about this offline with anyone as well. And just to kind of give a little bit of an overview about what we're going to be looking at. So we're going to kind of, I guess, if we think about project risk analysis, really the kind of the risk register is obviously a fundamental part of that. And where we've got a model where we can look at cost and schedule together, then that risk register can talk to both of those things together rather than needing one risk register for cost and one risk register for schedule. So we'll be exploring risk registers and estimating uncertainties and so on. We'll look at the schedule side of things and how uncertainty and risks and opportunities can have an impact on the schedule. I appreciate that most of the people on this call are probably from the cost side of things, but I think it's really important to understand what your colleagues in planning do if you don't already know so. And so I'll give a kind of like a little bit of an overview about what we're doing when we're talking about a schedule risk analysis. We'll then look at how risks and uncertainty in a cost model can have an impact on our project costs. And then we'll start to explore how, if we have got slippage in our schedule, even if we've got totally different source information for our costs and our schedule model, how we can still build these kind of links between schedule and cost, so that if an activity takes longer, it's going to cost us more. And then finally, we'll kind of roll the old Monte Carlo dice. We'll run a simulation, and then we'll start to look at some of these outputs that we get from the process. So talking about the histograms and the S curves, looking at things like sensitivity analysis and scatter plots and a whole lot of other hopefully cool stuff, if assuming that we've got some time. Now, in terms of just a few little kind of things to remember about this presentation, it's fair to say that there's going to be a lot of ground covered. Someone once described my delivery as being akin to trying to drink water from a fire hydrant. And so if you come that image, there's going to be a lot of information coming at you. And there's always a balance between trying to kind of show some really cool, exciting stuff, and not having to speak at a ridiculously fast pace and so on. And so I'm not going to promise that people are going to leave the session being able to do these things tomorrow. Hopefully, if nothing else, really the idea of it is to kind of give some inspiration about things that you might want to consider in the future. And Megan's been kind enough to host us today. Always very, very, very happy to talk about anything to do with QRA to anybody who wants to talk to us. So if you want to have any kind of follow-up sessions afterwards, I think we'll probably send around an email. I think we'll maybe get access to the attendee list and send around an email. But please add me as a connection on LinkedIn and just get in touch if you want to know any more about anything we're talking today, software training, consulting, anything at all. Now, because we're going to be talking about lots of kind of concepts, it's much, much easier, in my view, to show those live using software rather than an endless stream of PowerPoint slides that aren't very dynamic. So the tool that I'm going to be using is a tool called Safran Risk, which is really, I talked about PertMaster and PRA at the start, and really Safran is the in my view, the next generation version of those tools. It's got the same developers from PertMaster back in the day. So there's this shared kind of development DNA in it. It's something which we use an awful lot. Ferryfield use an awful lot. We're a very kind of strong partner of Safran. But it's not just a kind of this isn't designed to be a sales session on Safran. It's really talking about the methodology. And so what I'm the stuff that I'm going to show in Safran, you could just use for QSRA or for QCRA for quantitative cost risk analysis. You could do it in different tools. You could even, if you had sufficient time and energy, build it together, build it all up in one place manually yourselves. And good luck to you if you want to try doing that. And really, I guess the purpose is, as I said, just to really kind of give some ideas about how, what are some of the developments in the space of integrated cost and schedule risk analysis? What are some of the things that you can do that maybe you didn't know about previously, and also maybe some of the exciting things that you can end up finding out about your projects that should really hopefully have a positive impact on your organization or your project outcome. So hopefully everyone is can see the level of enthusiasm and passion that I have for the subject. Having been doing this for a long time, I appreciate that QRA is not really everyone's cup of tea. So I really appreciate everyone making the time on your lunch breaks or wherever you are in the world to come along and have this session. Try and be as enthusiastic as possible about the material. And I think that QRA is something that really rewards people. The more you put into it, the more you get out of it. And hopefully I'll generate some enthusiasm. And anyone who's ever spent more than 5 minutes in a room with me will know that I'm a big fan of the Mike Tyson quote about kind of everyone's got a plan until they get punched in the face. So whatever the agenda was that I put up at the start, things go wrong on presentations. So I will try and finish on time, but I'm not a scheduler by background. And so in the event I end up overrunning, people want to kind of have questions offline afterwards, I'm always very happy to host them. So with all that said and done, let me close down. Oops. Thank you. Maybe a teeny bit premature at this point, but we'll make sure you get the presentation as well, so you have all this to refer back to if you want to. So let me close down my my presentation and jump into Safran. Okay. So for those of you who haven't seen the software before or looked at the tool, as the screen says, welcome to Safran Risk. So it's a really kind of convenient tool to use for this sort of presentation, because what it allows me to do is to have everything in one place. And so I've got a model here where I've got, you can see on the home screen, I've got, it's a really simplistic little example model. I could do this with 100,000 activities, but it's a lot harder to explain a model, to talk through a model with that many activities or risks or costs in. And so it's a very high level project that kind of allows me to cover everything that I need to within the session. So we've got 30 activities, we've got 21 risks, and we've got 18 costs, and we'll look at where all that information comes from in a moment. But in terms of what you're seeing here, the software there's a database in the background, and so typically speaking, organizations will have their schedule in Primavera P6 or maybe Microsoft Project. You might have your costs, Postos or POPA or Aries Prism or SAP or whatever else it might be. And then your risks might be in Excel, or they might be in a risk management database like ARM or Risk Connect or Risk Hive, whatever flavor of risk management tool that you want. And so really what we're kind of looking at here is a tool which allows us to interface between those different those different elements, so that rather than having our data in disparate places, actually what we're doing, we're bringing it all into one place, and then we're building in some links between them. So let me kind of give a quick run through about the order in which we're going to look at things. So I think as a start, I'll probably start off with looking at the schedule. I want to kind of give a baseline kind of overview about some of the things that we might want to think about from a schedule risk analysis. And if you're sitting there thinking I'm trying to teach you how to suck eggs, I do apologize. I think that I want to make sure that everyone's kind of foundational level is at a decent level before we start going on to the integrated side of things. There's no point in trying to run before everyone can walk. So I want to help with those kind of baby steps at first. And so we're going to look a little bit about the schedule side of things. Then we'll look at the kind of the interplay between a risk register and schedule, whether it's looking at duration, uncertainty, or risks and opportunities. Then we'll explore costs and how risks can interplay with those in different ways, and then we'll start to bring everything together. So let's kick off with the schedule. So you see I've got all these different tabs along the top, and so everything on the left-hand side of this Analyze tab are my inputs, and then everything else to the right-hand side are all of the outputs. So I want to kind of make sure I spend plenty of time on the outputs, because those are probably the most important thing for people. But we'll just spend a little while exploring the inputs together first of all. So if I go and have a look at my schedule here. So this is a schedule which has been imported from P6 or Microsoft Project. I can even build this in the tool, but let's imagine for the sake of argument that this is coming from P6. And so what you typically have on projects is you have something like P6 is your kind of like your your planning or scheduling software where that's your kind of single source of truth. And actually, I suspect that may be a little bit small, so I've just zoomed in a teeny bit. And so this is a schedule that for a really simple project. So it's a project where I've got these 6 different phases. I've got prelim, design, fabrication, construction, and testing, and an on-site reconstruction. And it's a manufacturing project to put together some kind of an unmanned aerial reconnaissance vehicle or drone, more simply. And so this is a kind of like a really simple model. So if you think about what tends to happen on projects, you tend to have your project management system is something like a P6 where all the activities are listed, and that's where you kind of manage the kind of like the flow of time and work on the project. And so what we've done here, we've just kind of imported it into Safran. And so this is essentially a version of that P6 schedule, but it's being rendered or represented in Safran. It kind of uses this Safran project, which is a kind of project management tool in its own right to really kind of represent the schedule. So rather than it being an API connection to P6, what we've got a version of the schedule in Safran that we can then start to manipulate and play with. And from experience, planners don't particularly like it when you play with their schedules on their live operational system. So there's some real kind of advantages from kind of taking that offline and doing that somewhere else. So we've got a schedule, and you can see here we've got some the Gantt chart over on the right hand side, and most of these are kind of finish to start links, looking at the kind of the logic and the flow through these. Now, in this particular model here, we've got some 3-point estimates for duration uncertainty that have already kind of been built in by the planner. And so sometimes this is something we see where in P6 you have a 3-point estimate for your minimum, most likely, and maximum. We can't do Monte Carlo in P6, and so although those values might have been created, actually, from a duration uncertainty perspective, they don't really mean all that much until we put a distribution with them and start running a simulation. And so what we've got here is we've got a schedule. And this schedule is one which at the moment is essentially a deterministic model. So it's a single point estimate for my duration here, and then that's governing the Gantt chart on the right, and I've got a finish date of the 3rd of April over here. And so, obviously, when we're running a simulation, we want to move away from this deterministic world into a stochastic or probabilistic world where we can show lots and lots and lots and lots of different scenarios and how they all start to fit together. And at the moment, I haven't actually run a simulation, which is why up here you can see that I've got a P50 and a P90 duration, which is just left blank at the moment because I didn't run a simulation. I don't know what those things look like. So when we're on a Monte Carlo, what we're doing is we're generating lots and lots and lots of samples or iterations for each of the inputs to our model. And so in this particular model, I've got some duration uncertainties, and I've also got some various kind of some risks and opportunities, and also some estimating uncertainties as well here. And so this is the kind of like the risk register, and the risks in our risk register, they can either be to do with the schedule, they can be to do with the cost, or indeed they can have some kind of an impact for both of those elements. And so, for example, this one here, I've got a risk of an ash cloud closing some flight corridor, which it may in turn mean that I can't get the materials or labor, or maybe I can't do the testing or whatever it might be. And so if that happens, we've got an impact to our schedule described up here. And so what this is basically saying is that, if this event happens, there's a 40% chance of this. I don't know whereabouts this is, probably not the best place to live near if there's a 40% chance of an ash cloud causing a flight corridor to close. But there's a chance that this will happen. And if this does happen, then the best we can hope for is that it's not going to affect us at all, which would be 100% of our duration is the baseline. But actually, it could have as much as 30% onto whatever activities this has been mapped across to. And down here, we can see that we've got some various activities that's been mapped across to. We've also got some cost impact here as well, but we'll park cost for now, and we will come back to that a little bit later on. We've also got things like some estimating uncertainties here as well. And so estimating uncertainties, whether we're talking about cost or whether we're talking about schedule, those are really things that we want to be able to use in order to capture the variability in the estimating process. We don't know how long something's going to take. We don't know exactly how much it's going to cost, and so there's some uncertainty there. And so with these estimating uncertainties, you see there's always a probability of 100% because we don't know exactly what's going to happen. There's just some level of uncertainty. And so where we're not very confident in our estimates, we might use something like a uniform distribution with a very wide range of outcomes. Whereas as we kind of become more confident, maybe we've done projects before, or we're kind of getting to the end, and those kind of sources of uncertainty are starting to reduce, to the envelope of uncertainty kind of starts to reduce as well. So we've got a kind of like a risk register here where we've got some risks and estimating uncertainties. And each of those things could have an impact on the project if it occurs. We can also put in things like opportunities as well. But here what we've got a risk register where we've got some pre-mitigated and also some post-mitigated risks or risk impacts as well. And so when we're talking about kind of risk analysis in particular, often the idea is that if we don't do anything, this is what we think might happen. Whereas actually, if we go and spend some money or time putting some risk management processes in place, maybe we can mitigate the impact if it occurs, or maybe we can control the likelihood and reduce the control the risk and reduce the likelihood of it occurring. And so when we're talking about a risk analysis, we often have these two different kind of components. Now, within the schedule then, so what we kind of do is we link these risks to activities in the schedule, or sometimes phases, or how much, depending on what level of we want to assign these risks to. And then we start the process of kind of running a simulation. And what we then see is that rather than having a model where the schedule is fixed in stone, actually we have a model that starts to move around a little bit, just to kind of show you how that works. This is when we run a Monte Carlo simulation, we might run with 1,000 or 10,000 iterations. What I'm going to do, I'm just going to do a manual version of a Monte Carlo, which is basically me pressing my mouse button and generating lots and lots of different samples manually. So the software's come a long way since the early 2000s. It's not something that you need to do manually, but it's something that's quite useful in a presentation like this, just to kind of give you some kind of an idea about what happens with these kind of all these risks and uncertainties. What are they actually doing to our schedule? And you can see that by virtue of the fact that these the amount of time is uncertain, or that there's these different risks or different opportunities, our schedule now starts to move around. We have these different iterations of the schedule. And actually, if I press the complete button and give my mouse finger a break, what you can see is that actually here what we've done is, after running a simulation, we've got a slightly different view on things. We've now managed to collect some data around the amount of time that these different activities might take, and now we might be able to start to see what kind of the spread or the variability is around our project schedule. And when we come to look at the results in a little while, we can kind of also then explore what our different finish date might look like as a result of this simulation activity. So when we're talking about the schedule side of things, obviously there's a lot more kind of in-depth things that we need to talk about, but essentially that's what we're doing. We're taking these probability distributions, these uncertainties that we require for our Monte Carlo, we're putting them against activities in our schedule, and then as part of a QSRA, unlike a kind of a standalone cost model, what a schedule risk analysis also then does, it also then takes into account the logic of our network in our project schedule. So all the finish links, the start links, the durations, everything kind of gets recalculated in a different way to you would expect in a standalone cost model. So there's some quite interesting things that happen as a result of that, which we'll come back and talk about in a little while. And of course, actually, one of the big things that we also want to do if we're doing a QSRA is to also make sure that we're working with a schedule that's fit for purpose. It's really important when you've got a schedule that the logic is all in place. You haven't got any danglers, which is an activity where there's no successors, because if you haven't got any successor tasks, it doesn't matter how long the activity itself takes, because it doesn't really affect anything going forwards. Likewise, if we've got these constraints in a model, which often planners are very, very fond of putting in a deterministic world, saying that a particular activity or milestone or activity must finish on or before a particular date. excuse me, that's something which can have a really big impact on our ability to do a QSRA. So, as part of the kind of the initial piece, before we even run a QSRA, often we're kind of looking at these things to make sure that our schedule is fit for purpose. So on the schedule side of things, then we've got a series of risks and uncertainties which are impacting upon our schedule. And if we're, when we then start to bring all those things together, what we essentially have is we have our WBS over here, and then on the right hand side we've got a list of all the different risks and opportunities and estimating uncertainties. And then what we're doing in a kind of risk workshop, we might look at an activity, and then with the engineers working on our ship to site processes or whatever, we might go through saying, okay, which of these different activities could be impacted by these different risks in our risk register. And the process of building up an overview of our risks is often about that interaction between the risks in the risk register and how they can affect our schedule. But of course, actually, I guess the clue is in the name. Most of you guys are going to be more interested on the side of things, the ICEAA, and what we're going to look at in a moment is we're going to look at a couple of different approaches that we can take from a cost perspective, and then we're going to look at how we can then bring together the WBS and the CBS to get this idea of these time-dependent costs, so to capture the link between an activity and the amount it's going to cost within our model, and then we'll look at some of the benefits we get from doing that. So, if you think that this schedule here has been created in a project management system like P6, a resource loaded schedule, the addition to a resource loaded or cost loaded schedule would be that each of these activities within the model might have some different resources allocated to it, and then in turn those resources might have a particular cost or quantity, and we can start to build up a view on our costs. But everything is driven by the WBS. But of course, most cost people, you don't think in terms of the WBS. You think in terms of a CBS or cost breakdown structure. So although we can still resource load, really one of the I think the big benefits of a tool like Safran and kind of what that kind of guidance from the AACEI was talking about was the fact that we could also have a set of costs which come in from a totally different place to our schedule. And so what we've got here is a cost model, a cost breakdown structure model, or CBS model, that's coming from whatever cost estimating or cost management software that we might have used. Often with those things we do an export to Excel, and at some point in the distant past, maybe someone has put together some kind of a series of cost information in a cost management tool and plonked it into Excel, which is kind of what I've got here. And then that's been kind of uploaded into Safran. So this is really a series of costs that's been built up independently of the schedule. And so this particular CBS or cost breakdown structures, we've got it categorized down into material costs, labor, other costs, etc. And this is the kind of the sort of thing that you might previously have, if you wanted to do a cost risk analysis, you might previously have got those things into Excel and then use that risk or a crystal ball or a model risk in order to understand what your cost risk exposure looks like. But actually what we've got here is we've got a kind of a full cost uncertainty model, albeit at a fairly high level of granularity. And so what we've got some material costs where we've got a base value, and then we've also got a distribution around that. So there might be this one here, for example, there's some parts for fuel system, 6 million. There's some uncertainty around how much that particular item might cost. And so once again, we're running a Monte Carlo on the cost model. Likewise on the quantity, the quantity could be fixed in stone, or we could put a distribution around it as well. And so all this stuff over here is kind of reasonably straightforward kind of cost modeling. But of course, part of the reason why we might want to move away from Excel is then the ability to start to bring in our schedule and to utilize all the expertise of the planning and risk team and feed that into looking at cost escalation and so on as a result of activities taking longer. And so if I just scroll across to the right hand side, just being slightly cognizant of the time, I've got in fact, let's just delete that out. I've got a particular activity here, this PMO cost. And so the PMO cost, although I've got a fixed value here, actually, for the sake of argument, what I'm going to assume is that the cost of my PMO is going to be in some way dependent upon the activities within my schedule. So if things take longer for some reason, I'm going to have to pay longer. I'm going to have to pay more for this particular item within my cost model. And so, although I've got a fixed amount here, actually, what I'm going to do, I want to link this to something in my schedule that then is going to allow my schedule to drive this cost in some way. And so the place I'm going to do that, I've got somewhere down here, I've got a little kind of, I'll call it a PMO hammock for costing. And essentially what this PMO hammock is doing, it's running for the duration of this particular phase over here from the 7th of December to the 3rd of April. So 118 days in total. And what that's going to allow me to do is to basically kind of attach a cost or an item in my schedule, link it to something within my cost model. And so over here, I've got a slightly convenient figure of 3.54 million. And the reason I say it's convenient is that if I scroll across to the right hand side, at the moment that's kind of fixed in stone. There's no kind of variable rate or time dependency within here. And so what I'm going to do, I'm going to link that PMO cost item to an activity within my schedule. And so I've just ticked the box here to say I want there to be a schedule connection. And you'll see that now I've got this split between fixed and variable costs. But of course, I haven't actually linked it to anything in my schedule yet, which is why I've got no variable costs and everything is fixed. And so what I'm going to do, I'm just going to click here, and this is what we call a WBS selector or work breakdown selector. I'm going to go and choose the activity within my schedule that I want to drive my costs. And that hammock that I've got set up seems a convenient way to do that. Now the assumption here is that everything is time dependent. So if we complete it, if that phase is done quickly and the amount of days required is low, that's going to be a good thing. If it takes longer, that's going to be a bad thing, and the activity is going to drive our costs completely. We could put down a different fraction here. If we said, well, we've got split between fixed and variable, we could do that, but I'm just going to leave it as 100% for now. So if I click on OK, what you'll see is that we've got for this particular activity, we've got a duration of 118 days, which the convenient part here is that it gives us a nice, easy to remember day rate of 30,000. So what that means is that in a deterministic sense, we've got an item in our cost model, we've got a line item in our cost model for the cost of this particular activity, and we've got the activity itself, which has got this 118-day duration. And so what that means is that if we were taking like a daily rate for that, every day that this activity or this hammock lasts for is going to cost us 30,000 onto our project. Now, of course, this is in a deterministic world. We don't need to do this step. But of course, when we start to build a probabilistic model where our activities start to move around depending on how long they take, what's going wrong with our project, actually, what we want to see is much like the when I was doing that kind of step through before, what we would want to see is when this this duration down here for the hammock is shorter, we want it to cost us less. When that hammock takes longer, we want it to cost us more. And so if you think each of these days here is equivalent to 30,000 bucks, then when we look at this in the cost model, we can see here this is our schedule model. And so, whatever's happening in the schedule model is reflected within our cost model. And so here, because we've got this link between the cost and schedule, you can see that this particular iteration has 140 days in my schedule. So that's the value that we've got down here, 140 days. And so in my cost model, it's 140 days. We've got that day rate of 30,000. And so whilst previously that was our kind of our baseline cost in our non-time linked model, actually now what we've got a variable cost this iteration of 4.2 million. So we've had this extra money added by the fact that it's taken longer. And so this time it's shorter, this time it's longer. And so we've got these links now between the schedule and the cost that we just didn't really have before at that kind of level of granularity. You can see also that we can also start to apply these risks from the risk register as well. So just as we've got the risks which have an impact on our schedule, these risks down here are all things which can have some kind of an impact in terms of our cost. And so when they're flashing up, it means that this particular iteration, this risk occurred, and then that's kind of having some impact on our costs. And so the idea here is that this cost module is really, it's designed to kind of replicate the sort of thing that you build in Excel, but with the added benefit of being able to then build in these links to the schedule that just weren't there previously. Now, there's plenty of other things that I could talk about on the input side of things. I could talk about things like the probabilistic risk calendars, where the amount of time that something takes is being impacted differently depending on risks that occur at different levels of likelihood over the course of the year. We could talk about things like correlations, looking to build in relationships between different elements, uncertain elements of our model. But because we're still reasonably short of time, let's kind of look at then about what happens when we start to bring these things together. So first of all, what we do is we'd run a simulation. And so on the left-hand side, these are all the different risks that I could choose to include. So I could either have them at the pre or post-mitigated state, or indeed some kind of blended position. Get to choose things like the number of iterations. Do I want to include my duration uncertainty? And also set up things like particular milestones or costs that are of particular interest to me when I run a simulation. So then once I kind of run the analysis, of course, what we're then starting to do is starting to build up some different bits of data. And so if I was looking at the schedule, whether I was looking at this on a purely schedule perspective, just from planners using this to understand what the outcomes look like for their schedule, I could look at the things like the finish date for my project. So I might have in my model, you might remember I said the 3rd of April completion date, and I can see that as a result of those risks and opportunities and estimating uncertainties, I've got maybe a 30% chance of actually meeting that particular objective. If I wanted to move from a 30% probability to more like a P90, so 900 out of my 1,000 iterations, what value would be sufficient in order to complete my objective before that particular project, before that particular point. I might need to add on an extra 78 days of contingency to move from a deterministic to a P90 world. So whether we're looking at the kind of the overall project or the individual phases, we can start to drill down in things from the schedule perspective. Now, of course, you guys might not be interested in the schedule, and so let's have a look at the costs instead. And so over here, we've got another distribution graph where we've got the where we've got things like the histogram, we've got the S curve, we've got this again, we've got a contingency curtain showing us the distance between the deterministic and the P90. But over here, what we're looking at our costs. And so here we've got our cost breakdown structure instead, where we're breaking things down by material or labor or whatever else it might be. And so once again, this is being whilst the schedule was being driven by the duration uncertainty and then the estimating uncertainty and the risks and opportunities, the costs are being driven by things like the uncertainty around quantity, the uncertainty around what the actual kind of base value might look like, as well then as the impact of risks or opportunities, and also these links between the schedule and the cost that we just explored. And so both these kind of schedule and cost results, they tell us what the landscape might look like on our project if we were looking at cost and schedule independently. The next kind of step is then typically people might want to start looking at things like the sensitivity analysis. What are the aspects of my schedule, the activities that are in some way having an impact on my project completion date, or what are the things that are really that are driving my cost outcomes, and start to look at what's moving that dial. What is it that's affecting our outcomes the most? Now, one of the kind of really massive improvements that Safran has over PRA is the ability to do something we call sensitivity analysis by exclusion, which is where in PRA you have to run like a whole series of simulations and write down lots of results and calculate deltas and so on in order to understand the cost or time impact of risks from the risk register. But what I've just done is run this this sensitivity analysis by exclusion. And what that's essentially telling me is that out of all these different kind of risks and estimating uncertainties and so on within my model, if I was looking at it from a schedule perspective, the thing which is having the biggest impact on my model at the P90, so that's the kind of metric I'm maybe interested in, is this weather downtime. So the wind speed's too high, I can't do some of my testing on my drone. And actually at the P90, the impact of that's going to be 23 days. This ash cloud, this flight corridor, that's 19 days, and this estimating uncertainty. We've got these things which are having an impact to our schedule. And of course, because we've got cost and schedule risks in the same place, actually, if we wanted to, we could look at our costs separately. So it might be that when we're looking at the costs, we have a different set of drivers that are having an impact on the costs of our model. Estimating uncertainty here, we've got some duration uncertainty on these guidance systems. These are a different set of key risks or key drivers, excuse me, compared to the schedule. But of course, one of the really kind of big benefits of having a holistic model like this is we can actually start to look at both of these things together. So rather than having your schedule team saying, right, these are my key risks, these are the things that I want to kind of do in order to kind of to make sure that I don't overrun on my project schedule, and the plot team saying, right, these are the things that we need to do in order to keep our cost outcomes as low as possible. What we can now start to see is, we've got this shared risk register. And so if you were looking at it purely from a schedule perspective, that weather downtime risk is going to be the key one. Whereas if you're looking at it from this perspective, this element here is going to be the key one. And so when we talk about things like stochastic optimization, which sounds like a very big kind of big word, what we can now start to do is to try and figure out exactly what it is that we want to do for our project to really help deliver outcomes that kind of affect both cost and schedule. So having something where we've got a holistic model with everything in one place, it gives us this capability we just can't do if we've got two totally different models that are just divorced from each other. And what it also does as well, this kind of approach also really, it can highlight inconsistencies in our model. Because for me, I did a training course last week, and one of the things that I kind of observed in the training course was that, this key risk from a schedule perspective, this weather downtime risk, which is 23 days of impact to my schedule. Actually, I've got this negligible cost impact here. Why is that the case? Does that seem right? Doesn't seem right to me. Maybe actually, if it's going to take a load of extra time on my schedule, then surely that's going to have an impact on my costs as well. Okay, right. Well, let's figure out how to get that into our model. Let's go and understand how we can wire that together in order to make that a bit more reflective of what we think might happen in reality. So this sensitivity analysis is just such a really powerful part of this kind of this integrated cost and schedule piece. It's a really useful thing to be looking at. Now, whereas the cost and schedule graph here are separate. Actually, if we go to the scatter plot view here, what we've got, basically the scatter plot is a way of almost like flattening out our cost and time results and putting them on one scatter plot. And so along the x-axis we've got the finish date, and along the y-axis we've got the cost. And so each of these little dots on here represents one iteration of our model. And so in this particular case, iteration number 965, we finished on the 22nd of July and it cost 20.8 million. And this dot over here was iteration 798 and finishing on this date and this cost. And so what this is telling us is that actually, if we look at the results from our schedule, we can see we've got a 29% chance of finishing within the time of our project. We look at the cost, we've got a very high 56% probability that we're going to be able to meet our deterministic cost of 16.6 million. But actually, if we look at those two things together, although we see we've got a 56% of that we're going to finish kind of less than this line here, which is that deterministic value of 16.6 million, and we've got a 29% chance that we're going to finish to the left of this line here, which was my 3rd of April completion date. Actually, we can see that if we look at both of those objectives together, we can see that if we talk about cost and time together, we've got a 21% chance of meeting both of those, which is something we would call a joint confidence level. So rather than looking at P80 for cost and a P80 for schedule, or saying that we've got a P56 for cost and a P29 for schedule, if we look at those two things together, we've got a 21% chance of meeting both of those objectives together. And of course, we can tweak these graphs and look at kind of the optimal level of contingency is, cost contingency is, in order to, what does that then do to our schedule outcomes and so on. But again, whether we're looking at something like these scatter plots here, or these JCLs, which NASA have played such a big part in kind of popularizing recently, where we're starting to look at, the rather than projects being sanctioned at the P80 for cost and schedule, actually what we're going to do, what we require is a JCL of 80% or more. And so when we look at sanctioning projects, actually we need to make sure that we build up a model where cost and schedule are looked at together in order to come up with this kind of joint approach to project sanctions. Now, a couple of other quick little things before we wrap up the questions, and I take a much needed breath, or at least my sort of dry throat does. Because we've now got all these things in one place, what we can now also start to do is to almost kind of bring out this time phased probabilistic cash flow, where we look at what our spend is over time. And so, if I was doing these things independently, I might be able to run a simulation and see that I've got a P90 for my cost of 18.07 million. But actually, that 18.07 million, although I might have spent that by the end of my project, I might also want to know, how much am I going to be spending in year one? How much is going to be in year two? How much do I need to have, in my budget by the end of 2025, or whatever I might need to the information I might need from my treasury department, or budgeting, or cost control, whatever it might be. And so because we've got cost and schedule in the same place, and we can link that together, and so we can, in the cost model over here, when we're setting up these types of things, we can say, what's the time horizon for the spend? Is it, do we if we've got something where it's linked to an activity, let's make sure that we budget across the activity, so we can start to build in these links and start to say when we want these spends to occur. And so by doing that type of activity, what we're saying here is that this is my annual spend. And so the red bar would be my P50, the orange is my P80, the green's the P90, and the blue's the P99. And so I can see what I'm spending at a given level of confidence in each of these years of my project. Which are those bars, and that's the kind of that y-axis on the left-hand side is my periodic cost, and then on the right-hand side is my cumulative cost. So if we take these points on this cumulative curve as how much we've spent up to a particular point, I can see that by the end of my project, if I was looking at the P90, I've got that figure of 18.07 million. So I've got that's what my distribution looks like. But actually here I can also break down exactly how much I might need to spend at a particular point in time. And of course, when we're talking about scenario Monte Carlo, a lot of it's not just a kind of static process. Often we're looking to understand what would happen if we do things differently. If we go down this contracting route rather than single sourcing, if we put out these work packages rather than this, if we do these activities rather than these ones, what does that then do to our outcomes? If we control these risks, if we put some money on mitigation or controls, how does that help us? And so a lot of the kind of process in Monte Carlo is not just about coming up with a P90 or P80 or whatever it might be. It's also about trying to understand how we can do things differently in order to kind of have a positive impact on our costs. And so looking at things like comparing things like our original uncertainty estimate versus our pre-mitigated costs, and then seeing how much we might be able to kind of reduce our exposure to a given level of confidence. Again, having everything in one place just makes all these things a lot easier. And so we could look at things like different versions of our cost model, or different versions of our schedule. Looking here, instead this, rather than looking at the pre and post mitigated costs, what we're looking at here is what our completion date is of our project, initial estimate versus stage gate 2 versus stage gate 3, and we can look at what those look like over time. And so being able to kind of start to put all these things together, it just enables us to have a kind of much richer, vivid set of data and insight on our projects. And then, of course, not necessarily something which people might be interested in from a pure cost perspective, from a scheduling perspective. Certainly, where so much is so much is dominated by talk about controlling the critical path and controlling the activities on the critical path as a way to project success. Actually, as soon as we start to run a simulation, when we start to run a simulation, we have a schedule that starts to move around. We have risks and opportunities dropping in and off. We might have different activities coming on, and actually, when we start to run a simulation, actually we end up not with just one critical path, but we sometimes end up with a whole series of critical paths. And so, what we can also then do when we run a simulation, we can then look to kind of to understand what these different critical paths might look like, and where they might start to kind of diverge on our project, and also where what the outcome of those things are. So there's obviously lots more that I could talk about. I've tried to kind of cover stuff in as high level as possible, whilst also kind of painting a picture of the whole. So I appreciate there's been a lot of information that's been thrown at you. So I'm going to pause for breath. I will reiterate that if anyone wants to talk about this in more detail or slower detail, I'm very, very, very happy to do that offline afterwards. But for now, I shall stop myself talking and pass over to Megan for kind of wrap up and any questions in this remaining 4 minutes. Megan, over to you.
Well, thank you so much, Doug. I do have to say you kept up your promise with the drinking from the fire hydrant.
Yep.
And you may have stunned everyone into silence. So it looks like we don't have any questions right now, but I encourage all of you, if anything you're seeing has intrigued you or caught your eye, and it looks like this is something that can help you, reach out to Doug, reach out to Craig and the guys at Ferryfield, and they will be happy to assist. I'll be posting the recording of this on the website tomorrow. And also the slides, if you would give them to me so folks can download and you can share them with your friends.
Absolutely. No, be very, very happy to send those across. Yes, lots of ground covered. I'm actually quite pleased that there's no questions, because what it hopefully means is that people have been concentrating too much on what's been going on and haven't wanted to look away in order to start typing stuff. So yeah, I'll take that as a good sign rather than a negative, hopefully.
Doug, Ralph did have one question. I don't know whether you saw that.
Yes, that just popped in. We have a question from Ralph Estrada that says, risk register development drives the risk analysis. It's critically important. Exactly.
Absolutely. And yeah, more of a statement than a question. And yeah, I agree. I think all things are kind of equally important, Ralph. I think you can't do a good schedule risk analysis without a decent schedule. You need to have a really good risk register in order to understand how everything fits together, and the same for costs as well. So I don't think anything's more important than the other, but I think it's really important to do things together in order to get to that level of kind of project risk modeling maturity, which it's I think I said in one of the slides at the start, it's very much it's not a destination, it's a real journey to get there. And so hopefully today's kind of opened up a few kind of questions and so on for people, and have just kind of brought to light something which you might not have known previously. So as Megan said, if anybody wants to talk about any of these things in more detail afterwards, please get in touch, and I'll be very, very happy to talk to anyone who wants to find out more. So Megan, thank you very, very much for inviting us along. Thank you very much to everyone else for your attendance. Hopefully that drinking from a fire hydrant hasn't exhausted everybody too much. And I wish you all a very enjoyable afternoon/evening, and hopefully our paths will cross again before too long.
Well, I couldn't have closed it better, so let's leave it at that. Thank you so much, fellas. Everybody have a good rest of your day, good evening, good afternoon, and be good to each other. Take care.
Thank you very much. Cheers, everybody. Bye-bye.
Take care, everyone.